Hello, and welcome to the equation of a line. My name is Tuesday J. Johnson. I'm an assistant professor at Doña Ana Community College and a lecturer at the University of Texas, El Paso. This is for Math 120 at Doña Ana Community College, also at New Mexico State University. Intermediate Algebra. Chapter 3 comes to us from the XYZ text, Intermediate Algebra by Turner and McKeague. Chapter 3, Linear Equations in Two Variables and Functions, specifically Section 3.3, the equation of a line. Let's start with a definition. The equation of any line with slope m and y-intercept b is given by y equals mx plus b. The slope, m, tells us the tilt of the line, and the y-intercept b tells us the specific point, which is 0, b, at which the graph crosses the y-axis. This is the y-intercept. So let's write the equation of the line with given slope and y-intercept. If slope is -6 and the y-intercept is 4/3, I replace my m, I replace my b. So I'll have the equation y equals -6x plus 4/3, right? mx plus b. If m equals 0 and b equals a -3/4, I can still replace y equals 0x minus 3/4. Oh, we have a typo here. Let's put it in appropriately. If you don't want to write the 0x, that's all right. 0 slope, we generally don't see it anyway. A 0 slope, remember that's a horizontal line. That'll have equation y equals, and in this case, y equals a -3/4. So previous lectures, we've talked about parallel and perpendicular lines, and a parallel lines, as long as they're non-vertical, have the same slope. And two non-vertical perpendicular lines have slopes that multiply to be -1, or alternatively, we could think of it as the slope of one is the opposite in sign and the reciprocal of the other. So if I'm given a line, y equals a -4x plus 1, I know my given slope is -4. The parallel slope is the same, so m equals -4. The perpendicular slope is opposite in sign, so it's positive. Reciprocal, so if I flip over 4, that becomes 1/4. If I multiply -4 times 1/4, I will get a value of -1. I know it is the perpendicular slope. 2x minus y equals -4. In order to talk about parallel and perpendicular, first we must solve for y so that we write it in the slope-intercept form. So I'm going to subtract 2x from both sides. -y equals a -2x minus 4. I don't like to be a negative person in general, so let's multiply or divide, whichever you prefer, every single term by a -1. That leaves me with y equals 2x plus 4, giving me a slope of 2. It's only after we get positive y isolated that we look to the slope as the coefficient of x. The x is not included in the slope, just the coefficient of x. So the given line has a slope of 2, parallel slope is 2, perpendicular, change the sign so it's negative, a flip over the fraction, we get 1/2. I know 2 doesn't look much like a fraction, but don't forget 2 could always be written as 2/1, and then the reciprocal is a lot easier to see. 2/1, flip it over, 1/2, change the sign to be negative. So, for the given equations in these examples, we're going to find the slope and the y-intercept for each of the following, and then we're going to sketch it using the slope and the y-intercept and talk about a perpendicular slope. We're doing a lot here. So, given y equals 2x plus 3, I know that m equals 2. And just as we saw in the last slide, a slope is frequently given in fraction form, and the reason for that is because it's rise over run, right? Change in y over change in x. So I'll rewrite 2 as 2/1. And the 2/1, a positive 2, tells me to go up 2, rise. A positive 1 in the denominator tells me to go over 1, and I said over, but I should have said to the right. A positive 1 goes to the right. So what I can do with my b value of 3 is first I plot the point 0, 3, my y-intercept. From b, I'm going to go up 2 and to the right 1, and I have a new point. So from my y-intercept, I use my slope to find a second point, draw the line between them. If my slope is 2, a perpendicular slope is -1/2. just so we practice that perpendicular idea. In the equation 3x minus 2y equals 12, in order to find the slope and the y-intercept, I'm going to solve for y. So I'm going to subtract 3x from both sides. And then I'm going to divide every single term, there are 3 terms, by negative 2. Negative 2y divided by negative 2 is y. Negative 3x divided by negative 2, a negative 3 over a negative 2 is a positive 3 halves x. 12 divided by negative 2 is negative 6. I see my slope is 3 halves. My y-intercept is negative 6, so I plot the point negative 6 on the y-axis. From here, I go up 3 to the right 2. If you don't hit the line, make your dot bigger. Should be all good. There's my equation. Given slope is 3 halves, perpendicular has opposite sign, so it's negative. And flip over the fraction to get 2/3. There are other forms for an equation of a line, and point-slope form is one of them. Using the slope formula and a generic point xy, so instead of y2 and x2 here in our formula, it's generic x and y, we can find another way to represent the equation of a line. And we can do this by multiplying both sides of this equation by x times x minus 1, x minus x1. Let's say these words right here. And when I multiply on both sides, my x over x minus x1 cancels on the right. And you can see I have my y minus y1 from the numerator, I've written it on the left now, equals, and then m times x minus x1. So it comes directly from the slope formula. And we call this a point-slope formula because we know the slope, m, and we know a specific point, x1, y1. So this is very helpful if we're not given 2 points on the line, but we are given the slope and a point. So for each of the following problems, we're going to write the equation and put our answer in slope-intercept form. Point, -1, -5, slope is 2. We know that the point-slope form is y minus -5 equals slope 2 times x minus a -1. Let me simplify those subtracted negatives, so I'll have y plus 5 equals 2 times x plus 1 in parentheses. 2 times x is 2x. 2 times 1 is 2. And to get y by itself, I'm going to subtract 5 from both sides. 2 minus 5 is a -3. So I'll have y equals 2x minus 3. For the slope-intercept form, a line with a slope of 2 that passes through -1, -5. If I have a point -2, 1 and a slope -1/2, I can use the point-slope form. Y minus 1 equals -1/2 parentheses x minus a -2. Let's simplify that to be x plus 2. When I distribute my -1/2, I'll have -1/2 times x, -1/2 times 2. A negative times a positive is negative. Half of 2 is 1. When I get y by itself, I'm going to add 1 to both sides. And when I add 1 to both sides, it just so happens to cancel out on both sides. And so I'll have y equals a -1/2 x. Remember, this is the graph of a line with a negative slope, and it passes through the origin because there's no b value remaining. We have another form, standard form. If a, b, and c are integers, and a is either positive or 0, we call this non-negative. So it's positive or 0, then we call it non-negative. Then the equation of a line is in standard form if it's ax plus by equals c. We now have 3 different forms of lines. The standard form given, point-slope form, and slope-intercept form. All 3 forms have their benefits. So all 3 forms are something you should know. If you need to, pause right now, write these down on a note card. Standard form, point-slope form, and slope-intercept form. Learn them, know them, get used to them. Alright, so let's find the equation of a line that passes through each pair of points. We're going to write the answers in standard form. We can do this. -4, 1 and -2, -5. My first step is going to be to find the slope. So the slope is always y's subtracted divided by x's subtracted. So negative 5 minus 1 over negative 2 minus a negative 4. Negative 5 minus 1 is negative 6. Negative 2 plus 4 is positive 2. And a negative 6 divided by 2 is negative 3. I know my slope. Knowing the slope and using either one of these 2 points, I could use the point slope form. And I'm going to choose this first one. In general, I choose the point or one of the points that doesn't have negatives. But since both of these have negatives, the first point has fewer negatives. Maybe the numbers are, quote, easier, and easier depends on the person. But I chose this first one. You could easily use the other point, and maybe I'll show you that in just a minute. So y minus 1 equals negative 3 times x minus a negative 4. This is x plus 4, right, in parentheses. So when I have y minus 1 on the left and distribute my negative 3 times x, I get negative 3x. Negative 3 times positive 4 gives me negative 12. And rather than solving for y, I want to write it in standard form, so I'm going to add 3x to both sides, 3x plus y, and I'm going to add 1 to both sides to get a negative 11 on the other side. Now, I mentioned that it didn't matter which point I used, but why would you take my word for it? You don't know me. Maybe you do, but check it out. I could have done y minus negative 5 equals negative 3, trust me, that's a 3, times x minus a negative 2. Oh yeah, that's ugly. That's y plus 5 equals negative 3x. So this was subtract a negative 2, which makes a plus 2. But when I distribute my negative 3 times positive 2 is negative 6. I'm not going to get y by itself. I'm going to write it in standard form. So let's add 3x to both sides. And as I add 3x to both sides, I'm also going to subtract 5 from both sides. Why is that? Because now I have a 3x plus y equals the exact same minus 11. Yeah, I wrote a 6 there. I didn't mean to write a 6 there. That should have been a negative 5, the same as we had over here. Subtract 5 from both sides. Negative 6 minus 5 gives me a negative 11, the same equation I had if I used the other point. So when I say it doesn't matter, it truly doesn't matter. So let's try it again. Negative 6, negative 2, and negative 3, negative 6. I'm going to subtract the y values, negative 6 minus a negative 2. Subtract the x values in the same order, negative 3 minus negative 6. That's negative 6 plus 2, which is a negative 4. Negative 3 plus 6 is a positive 3. A negative 4 and a positive 3 make a negative 4/3. I'm going to use, I guess, this first point. Why not? Y minus a negative 2 simplifies to be y plus 2. Negative 4/3 times x minus a negative 6 simplifies to negative 4/3 times x plus 6. When I distribute negative 4/3 times x, no problem. Negative 4/3 times 6. 4 times 6 is 24. 24 divided by 3 makes 8. But this is not in standard form yet. I ran out of space. Let's look at the next slide. From y plus 2 equals a negative 4/3 x minus 8, I want to get the x's and y's on the left and all the numbers on the right. So I'm going to add 4/3 x to both sides, and I'm going to subtract 2 from both sides. It's very important that your coefficients must be integers, and especially the coefficient of x has to be positive. Remember it said a is greater than or equal to 0. So I can't have a fraction here. Without a fraction, I'm going to multiply every single term by 3. When I have an equation, I can multiply by any non-zero value, and it keeps the balance, keeps the equality. So 3 times 4/3 x is 4x. 3 times y is 3y, and 3 times negative 10 is negative 30. Standard form. for this particular equation of a line. Last example, last two examples. If I'm given the points 1 and negative 2/3 and second point -4 negative 2/3, I find that my slope is 0. When my slope is 0, and notice that y is negative 2/3 in both cases. All right? So if the y is the same, then it's going to be a horizontal line. Horizontal lines are always y equals, and in this case my y value is negative 2/3. Multiply both sides by a 3, and I'll have 3y equals negative 2, which is standard form for a horizontal line. On the other hand, if x is negative 4/3 comma 1 and negative 4/3 comma 3, the x value is negative 4/3 both times, I'm going to have an undefined slope. An undefined slope is going to give me the equation of a vertical line. But remember, we're going to have no rational expressions, no fractions, so I'm going to multiply both sides by 3, and I'll get 3x equals negative 4 for standard form. I must have the negative on the right side of the equal sign because the leading coefficient for my variables has to be positive. Once again, thanks for listening.